All right, beautiful. So the question we have today, as you can see, is 1 over x cubed plus x. So we have to integrate this. By integrating it, we have a large scale of usage. We can say that 1 over x cubed plus x integral dx can also be written as 1 over x cubed into bracket 1 plus x negative 2 all into bracket dx. Okay, further, we can also say that this is the same as 1 over x cubed, okay, multiplying 1 over 1 plus x raised to the power negative 2. Okay, then if that is the case, this we can also write it like x raised to the power negative 3 all over 1 plus x raised to the power negative 2. Okay, so we can say this can be written as this. So upon the integration, okay, then this, we say that let u to be equals to 1 plus x raised to the power negative 2. So when we differentiate this, okay, this will be du is equals to 1, that is 0, negative 2x negative 3 dx. Okay, so 0 minus that, we get 0 du is equal to negative 2x negative 3 dx. Okay, beautiful. Why don't you make the dx the subject so that we can substitute back to the equation? So we say u, okay, we say u du over negative 2x cubed is equals to dx. Okay, so by substitution, we will say that the integral of x negative 3 over 1 over u times du over negative 2x cubed. Okay, by cancelling, okay, if we cancel this and that, then we can write our equation, okay, as the integral du over u minus half. Okay, so we integrate this, we are going to get minus half the natural log of u plus c. Okay, but our x, our u over here is given as 1 plus x raised to the power negative 2. So when we put it back to the equation, then our equation, negative half integral du over u, is given as minus half natural log of 1 plus x raised to the power negative 2 plus c. Okay, so this is the integral. So our integral, okay, is now minus half natural log of 1 plus x raised to the power negative 2 into bracket plus c. So this is the solution for this integration. Okay, now let me take my time to explain the process. Okay, first and foremost, this is the equation that we've been given. Okay, so because of that, this equation, is so beautiful. There's 1 over x cubed plus x. 1 over the x cubed plus x. That is what we have. That's the integration. Okay, the same way, that's the integration. Okay, it's beautiful. This an integration given. Let me move this one up so we can have enough space to do our work. Beautiful. So, you know, is when we pull the x cube out of this equation, okay, then we can say that this equation, yeah, is 1 over x cubed into bracket 1 plus x raised to the power negative 2. So when we simplify, okay, we'll end up writing this equation as x cubed x raised to the power negative 3 over 1 plus x raised to the power negative 2. So we'll do substitution over here. We say substitution, okay? Substitution at this place. Substitution. So we say let u to be equal to 1 plus x raised to the power negative 2. So when we do the differentiation, then we have du over negative 2x cubed to be equal to negative dx. So this is negative, okay, negative x cubed, as we saw earlier, negative, yeah. Now, when we did that substitution, then we simplified it to resolve this equation to become negative half integral du over u. And when we do that, we know our answer that we get over here is a natural log of u plus c. But we know 1 plus x to the power negative 2 is the substituent. So we'll put it back to the equation, and this is what we get for our answer. Well, this is beautiful. This is beautiful. But when we look at a question properly, we see that, you know, when we go a traditional approach, you see this equation, as you can see, you know, somebody will say, why don't we put or pull out the x squared out of that, or x out of it, for it to be also be so easier for us to use old system or old means of solving this one. So let's see if we decide to use partial fraction, okay, partial fraction. So partial fraction will be the alternative method. But bear in mind, we have done the first approach, and this is what we got. Negative half natural log of 1 plus x to the power negative 2 plus c is our answer. Okay, so now we've decided to use the partial fraction. Somebody is telling me that to them this procedure is a bit complicated, so we should use partial fraction and c. So let's see whether what we're going to do will be able to help us to get the same place. Okay, so this alternative method, okay, so let's see. Our question is the integral. Let me use the white. Is integral 1 over s cubed plus 1. Okay, so this can be written as the integral 1, it will bring x out. This will be s squared plus 1, okay, dx. And if we look at the equation very well, we will see that this one, okay, is x squared plus 1. It's like more or less like a linear 1 over x. Okay, so what do? Let's set it up as partial fraction method. So our question will be 1 over x and s squared plus 1 should be equals to a over x plus bx plus c all over x squared plus 1. Okay, so when we multiply through by, we say multiply by x into bracket x squared plus 1. So our equation will be a out, okay, x squared plus 1, okay, plus x out, bx plus c is equals to 1. Okay, this, if you look at it, you see that this, we can resolve this equation so easy by expansion. So when we expand this equation, we are going to get ax squared plus a, then bx squared plus cx is equals to 1. Okay, when we put the like terms together, we have a plus b into bracket s squared plus cx. Okay, so bx squared plus cx. Now, if you look at the thing very well, you see that we are able to expand this. Let me make simple. You see that when we expanded this equation, we have ax squared plus a. Then the next one is bx squared plus cx equals to 1. Okay, so this is equals to 1. So by inspection, we can say that a plus b is equals to 0 because we don't have any value on the right hand side, because 0. Okay, then we say c is also equals to 0, but a is equals to 1. A is equals to 1. So let's put back our equations as we now know the value of a. Okay, is 1. And when we substitute a into this equation, we are going to get b to be equals to -1 and c 0. Let's put the equation back to the partial fraction. Then we have 1 over x, okay, then negative x over s squared plus 1. Now let's put this expression back into the form of integration. So this will be the integral 1 over x dx minus integral s squared plus 1 dx. Now, if we integrate this, our first one will be natural log of absolute value of x. Okay, now this integral x over x squared plus 1 dx, we can use substitution. So let u be equals to x squared plus 1, x squared plus 1. Okay, so we can say that du is equals to 2x dx. 2x dx. All right. Now let's put the these equations back into the integration. So this will be minus x over u. Okay. Then this will be dx to be equals to du over 2x. So we'll put it back into the equation. So this du over 2x. Okay, this x and this will cancel. So our equation now will be equals to the integral of integral of minus du over 2u. And this, we can further write it this way: minus half out the integral du over u. So when we integrate this, then we are going to get minus half out natural log of u plus c. Okay, this, what can we do? We know u to be s squared plus 1. Okay, so we put it back, then our equation will be minus half natural log of s squared plus 1 plus c. Okay, so finally, if we put the first one back, which is this, back into the equation, then our final integral will be minus natural log of absolute value of x minus half natural log of s squared plus 1 plus c. So this is the final answer for the integration. So now let's see. Somebody is asking me a question that the same integration, as we integrated it, we've got different values. Why is it so? And I said to them that, to me, I think it's the same. Okay, now let's do a bit of comparison and see. So if on our right hand side, if we have natural log of x minus half natural log of s squared plus 1 plus c should be equals to the first one, which is minus natural log of 1 plus x to the power negative 2. So that is minus natural log of 1 plus x to the power negative 2. These two are the same. Okay, these two integrations are the same. Totally the same. Okay, so this is the final answer. If you want to verify it, you just have to apply the principles of logarithm. Okay, bear in mind that, if you substitute values from 0 and above into this equation, and using a calculator to verify, the left hand side will be equals to the right hand side. Well, I leave that with you. You still can comment, and I want to see what you are going. I want to see your answers and your explanation why you think those two equations are not the same. Okay, so these two equations are the same. Thank you very much for your time. I know it's been a bit long, but it's the same integration that we have used two different methods to break them down. And thank you once again. See you around. Bye.